pessoal, eu sou o Nathan Vanier, um dos sócios da Grano Safe. A Grano Safe que é uma empresa que presta consultorias, treinamentos, também tem soluções digitais para indústrias e armazéns de grãos. E nós estamos começando hoje uma série de bate-papos, de conversas com especialistas da área que nós trabalhamos, a área de pós-colheita, armazenagem, industrialização de grãos. O nosso primeiro convidado é o Professor Griffiths Atungulu, da Universidade do Arkansas, Estados Unidos. Ele que é diretor do Programa de Processamento de Arroz da Universidade do Arkansas. Tem uma série de artigos internacionais publicados neste tema, sem dúvida para nós uma grande referência. E eu inicio agradecendo a ele por estar conosco e já vou fazer mais algumas perguntas daquilo que nos interessa, da parte que ele trabalha, o que ele vê de ciência por lá e dicas de manejo na área de secagem e armazenamento de arroz. So, Professor Griffiths, it's our pleasure to have you here today for this conversation. I was just talking to our audience, explaining that you are like a reference on rice processing. And I just want to first ask you about your background and your experience on rice in USA. So if you could just explain to our audience about it. So thank you.
Well, thank you very much, Dr. Nathan. This is a great pleasure to be invited here to talk to you. As he has mentioned, my name is Griffiths Atungulu, and I'm a professor at the University of Arkansas with a background in agricultural engineering, and a lot of my work is involved in rice processing and post-harvest systems engineering. I direct the program that is sponsored by several companies in the US, and all our work is focused on optimizing the rice quality, making sure that the processes are efficient, and ensuring that at the end of the day, the producers gain the benefits from the product that they produce. So thank you again very much, Dr. Nathan, for welcoming me to this place.
So it's our pleasure to have you here.
Yes.
So first of all, could you explain to our audience about the states in US that harvest rice, the main states that produces rice, and something about the rice production over there?
Yes, rice is a big commodity to us in the US, and primarily US produce almost 10 million tons of rice per year. And the majority of this rice comes from the state in Arkansas, where I literally come from. We produce about 50% of the US rice. The other 25% comes from California. And then we have states like Texas, Louisiana, Missouri, and Mississippi. All those combined produce the other 25%. So I would like to say that Arkansas produces primarily long grain rice, while California produces primarily medium grain rice. And Texas, Mississippi, in Louisiana, and part of Missouri, majority of those produce long grain rice.
So I think that you produce a lot of hybrid rice in US, I'm sure?
Yes, so Arkansas is especially leading in the production of long grain hybrid rice. We have the conventional rice, and we also have hybrid rice. Right now, rice breeders have done a great job, and we are having some very good cultivars of hybrid rice that are really astounding in terms of the yields that we are getting from the farms. And in Arkansas, where a majority of the rice is produced, I believe about 50% or so of the rice right now is hybrid.
So around 50% of hybrid.
Right.
And very different from our market. We probably have 1 to 2% of hybrid rice. Most part is conventional, pure lines. So what are the characteristics of the rice farms in US regarding the drying and storage management they have over there?
Yes, so just like I've seen here, I think majority of our growers are still using high temperature cross-flow dryers where they cut the rice from the field and then they take them to the grain elevators. It's dried at high temperature. So a huge percentage of that is still controlling the market, but we are seeing a significant rise in on-farm in-bin drying. And I believe this is catalyzed by some of the new technologies that have come in the market in terms of moisture content monitoring and automation of the fan systems during the drying. And then the other advantage is just majority of the farmers want to have really full control of their grain, sell it when they want to sell it. And so we are seeing a significant rise in on-farm in-bin drying. I would say right now about 30 to 40% of our industry is turning towards this on-farm in-bin drying. And that number seems to be just increasing as we go by.
So a lot of on-farm bin drying with low temperatures, probably a little bit different from the main systems you have in Brazil, where we use higher temperatures, even in the farm, with the modern dryers. And what about the quality characteristics of the rice in terms of head rice yield and also chalkiness? What could you talk about?
Yeah.
This kind of?
Yeah, those are important discussions. You know, quality is something that we are still striving a lot to improve. We have a few challenges here and there when it comes to quality. I would say that we are seeing head rice yield for some cultivars in the ranges of 55%, 58%. There are new cultivars that have come in the market. For example, our breeders have come up with some new cultivars. I'm aware of one particular cultivar right now that is giving a significantly high head rice yield. I would say that our average head rice yield are in the ranges of 55 to 58%. So broken grain is something that we are still struggling with, trying to see how we can mitigate that. We have cases where we have to deal with issues of high nighttime air temperatures, and this, once in a while we see cases of chalkiness that are attributed to that. And so we are working very closely, our breeding team is working very closely to see how we can come up with some high stress tolerant cultivars, cultivars that are resistant to heat or the high temperatures that we are experiencing during the rice growing season. So I would say chalkiness is one of those things that we're still battling with. But again, our breeders are doing a great job in doing that, in solving that. We also have issues related to what I would call pre-harvest issues like rice blast, disease. It's a fungi that attacks the rice. That in one way or another also impacts our industry in a big way.
I remember when I was at the Industrial Alliance meeting that you organized over there, and I heard about the high night temperatures. It seems a huge problem you have in US, and you need improved cultivars to avoid this problem. And how about the moisture content that the farmers harvest the rice in US?
Right. So typically, we hybrid rice or long grain rice and the medium grain rice can tolerate different harvest moisture contents. Most of the harvesting is done, in the range of about 16 to 21%. From our research, what we really recommend as the optimum harvest moisture content, especially for high temperature drying, is between 19 to 21%. That works very well for hybrid rice. It gives us an optimum milling yield. There is a correlation between the harvest moisture content and the head rice yield, which is very interesting because the lower the moisture content, harvest moisture content, the lower the head rice yield. The higher the harvest moisture content, again, we see lower head rice yield. So we always have to work with an optimum harvest moisture content. So for hybrid rice cultivars, from our research and what we are really recommending to the farmers is to try as much as possible to harvest at around 18% moisture content. When it comes to on-farm in-bin drying, this is a little bit challenging because many times it depends on the drying capacity or whatever type of fan that a farmer has on the farm. We discourage them from harvesting for on-farm in-bin drying. We discourage them from harvesting anything that is above 18%. Because we know that most of our fan systems are really not metered to give sufficient airflow to really dry the rice very quickly in those bins. And again, the weather conditions, the temperature, the relative humidity may also not allow quick drying of the rice. So 18% is what we recommend. We also have come up with some guidelines that really are geared towards minimizing things like discoloration. And so if you really want to minimize something like discoloration for on-farm in-bin drying, then you really have to dry that rice to very low moisture content very quickly. So we advise them to come to about 16% moisture content in as much as 10 days or so.
Yeah, so you see, you put the rice with 18% in the beans, and you need to have a very good airflow in order to remove all this water and avoid the yellowness problem with rice during this period, no? So you have several researches on rice yellowness. I remember to read some researcher from your group.
Right.
With different cultivars, you check in the different moisture content and temperature, and for how long the rice could be at that condition in order to avoid yellowness. So what could you tell to the farmers that are watching us about the conditions that will cause yellowness?
Yes, very good. Yeah, so our grading standards are very strict when it comes to yellowness, and sometimes just one kernel in about 500 grams of rice is able to shift that grade of rice. So yellowness is a very huge issue, or discoloration in grain generally is a very huge issue. Now, we have realized that there are two cases where we see this yellowness. Number one is when we have delayed drying of the rice. When you have delayed drying of the rice, where the rice stays at higher moisture contents for a very long time, that rice is likely to start to yellow. This is obviously because of the respiration heat that is generated because of the high moisture and the high temperature that the grain produces. Then we also in that scenario, or in that ecosystem where we have high temperature, obviously we expect microorganisms to start growing. And we have realized from some research that not only do these microorganisms contribute to yellowness in terms of producing heat, but there's also microbial staining that happens on the grain. And so delayed drying, excess respiration rate, microbial staining, all these are things that are likely to happen in the bean. To be able to avoid this, very important parameters that we are talking to our farmers is you have to be careful about what is your harvest moisture content. What's your harvest moisture content from the field into the bean? Number two, what kind of airflow do you really have in your system? How many CFM per bushel can your farm produce? Number three, what is your harvesting time? If you harvest in August and you put your rice in August, how much drying days do you have? If you harvest in September, how much drying days do you have? If you harvest late in October, how much drying days you have? And what I mean by drying days here is really the air has to pull the moisture out of the rice. For that air to pull the moisture out of the rice, it has to have a given amount of ability, what we call the equilibrium moisture content of the grain and the air. And so the drying days are important for you to be able to dry your rice to whatever moisture content you want. So considering all those factors, the harvest moisture content, what time of the year you have harvested your grain, what kind of airflow you have, you also need to think of, in your bin, what kind of new technologies do you have? For example, are you just going to blow the air in the bin continuously, or are you going to have some automated systems that can control the air that you're putting in? Are you going to heat the air as you put it in the grain? So all those factors really determine the recommended harvest moisture content that we advise the farmers to have. The general recommendation that we are giving to any farmer right now, who we assume is using continuous natural air drying, is to dry their rice to less than 17% moisture content in about 8 days. If you do that, you are able to avoid the problem of discoloration. What we've seen from our research, as long as the rice is at 16% moisture content, between temperatures of 10 degrees Celsius all the way to 27 degrees Celsius, that rice is going to stay in a good condition without discoloration and with minimum increase in microbial growth compared to what it was in the field. When the temperature exceeds 40 or 27 degrees, then you really need to bring that rice to almost 12.5% very, very soon, because again, above 27 degrees Celsius, we start seeing increased respiration rate, and we also start seeing some cases of overheating of the rice. Some enzymatic issues start coming in, and so you see discoloration not just because of microbial growth, but also some enzymatic reaction. So for temperatures above 27 degrees Celsius, moisture content between 12 all the way to 22%, we recommend that you really have to keep that rice at about 16%, at 12.5% if you're going to store it for a longer duration, like 16 weeks. So again, discoloration is one thing that we have studied a lot. And it's very, very much associated with the on-farm in-bin drying. Some cultivars are more susceptible to discoloration than other cultivars. And so we have come up with various guidelines to help us to reduce that problem.
Great. So in the cases where probably if you have the moisture content in 16% with temperatures like 25, 20 degrees Celsius, we may not see discoloration soon, but the mass loss will occur.
Right.
So I remember the mass loss curves that your department developed. I think that your team with Terry Sieben Morgan team. So this is something that the farmers and the industries needs to take care, because if we let the rice with 16, even 15% moisture content for a long period at certain temperatures, we may not see discoloration, but we will see the mass loss,
right?
And this impact the business.
That's true. So a farmer can lose just by storing good grain. A farmer is able to lose money in many ways. You can lose money just because you over dried your rice, right? Or you can also lose money because the quality changed during storage. But like you've mentioned, dry matter loss is a very subtle or very tricky way. It easily happens that farmers can lose money through that, especially if they're going to store their rice for a long time. And what we have observed is, anytime you have a dry matter loss of about 0.5% in the grain, that also is associated with some quality changes, which somehow also leads in the reduction of the value of the rice when it goes to the market. So again, we give a recommendation on dry matter loss criteria. We advise farmers to ensure that whatever the condition they are keeping their rice in, we don't achieve a dry matter loss of about 0.5%, because that obviously is correlated with a shift in the quality of the grain.
So that's nice. So we have heat stress, we have the grain respiration, the fungi associated. Is a very complex environment that we need to take care to avoid, the prejudice to the business, to the quality of the rice that goes to the industries. So how about the new research that your group is doing right now? What could you tell us about it? Which kind of topics do you think that will be very important for the future of the rice industry?
Yeah, so I'll talk in terms of what our group is doing. I mean, like I said, I'm directing the rice processing program, and the rice processing program is a team of several faculties with very multidisciplinary skill set that is brought together to solve issues in the rice industry. I deal primarily with post-harvest process engineering, but in our team, we also have faculty members who are carbohydrate chemists who look at the chemistry of rice, trying to understand how the chemistry of the new cultivars influences functionality of those rice in various market segments, whether it is an extrusion area or it is in a flaking business, and then we also have faculty members who are really looking at cases of how can we increase value, in the byproducts of the rice milling stream. When we are milling rice, we have just a ton of things that come out. We have the rice husk, we have the rice bran, we have several products. And traditionally, we have used these things for very low income industries. Most of them have been diverted to the pet food industry. But we are trying to see what other additional value can we get from these byproducts of the milling stream. We are trying to see, cultivars that are good for brewing performance. Rice is known for its uniqueness in terms of the gluten-free aspect. So can we use rice, for example, to replace beer? And if we replace beer, what is the flavor characteristics of rice? Can we breed rice that is specifically good for the beer industry? So those are some of the research that's going on. Other people are also trying to look at new technologies. Like my group, we are looking at new technologies for drying. We're trying to see if we can solve the problem of fissuring through use of something like microwaves, infrared drying. Can we use these technologies to minimize insect infestation, for example? We have new challenges within the rice industry, like mycotoxins, with multiple cropping, where a farmer is using the same bin to store rice and store corn, is using the same implement to harvest rice and harvest corn. We are seeing issues where there could be new challenges of toxin formation in the rice. So my group and a few other researchers, we are trying to look at technologies that can solve toxin formation. Another area that we are realizing is becoming very important to our industry, and again, this is one of the reasons why I'm making a lot of international collaborations with our teams in Brazil, is what can we do to automate, for example, our milling systems. Our milling systems can benefit a lot, from automation. We can save a lot of labor, we can improve a lot of quality, enhance efficiency, and just general overall production, if we can automate our mill. So I believe that those are areas that our industry need to keep looking at so that we can improve from a post-harvest standpoint. There are myriad areas that I believe we need to look at.
Nice. So in Brazil, during these last 2 weeks, you have visited some industries, right? So I just want to ask you about your opinion about our industries. What do you think?
Yeah, obviously, I know the Brazilian market is huge. You produce slightly more rice than we produce. I think in the America South and North America, I think you are the leading producer. We follow you very closely. And so I think we need to team up more, if we are going to improve our rice quality, rice production in our region, and to make our rice more marketable. From what I've observed just in my visit, I think we have a lot of things that we can learn from your industry. There are a few things that you can learn from our industry as well. But in general, I've been very impressed. I've been impressed by the kind of mills that I've visited. So far, I've visited one of your largest mills here, Camel. I visited another big mill in Arroz, Pelotas. I've visited Polisol. And I think I also visited Nelson Went. And so I was very impressed by all the operations, parboiling plant operations, the automation systems in these mills, the level of precision that you people have, whether it's in packaging or in just general processing. I've been so impressed, and the people have been so kind to me. They opened their doors and allowed me to learn quite a lot. So I believe it's time for us as teams in both parts of the continent to really collaborate if we are going to make our product very, very marketable. So again, I was impressed by the visit. Yeah.
That's nice. That's nice. So you mentioned the parboiling unit you visited, like Nelson Vent, Rosana Pelotas. And I remember that Dr. Ya Jane Wang, your colleague, was here last year with us, and she did a lot of studies on commingled rice and the risks for the parboiled rice industries. Do you also work with some commingled rice?
Yes.
This kind of
Yes. I do a lot of work with commingling, and commingling of rice is a big challenge to us. You know, we have several hybrid rice cultivars, and so it becomes a challenge for the milling industry really to segregate those and mill them on individual basis. And we know that, you know, if you don't segregate them because of the different attributes that they have, that might play into the quality of the product that you're going to use. And so I'm studying and collaborating with some economists, really, agriculture economists, first of all, to look at what is the benefit of identity preservation in the milling. Is there an economic benefit? Because we need to convince our industry that there is an economic benefit first before they can adopt such a method of segregation. So we are doing an economic study in collaboration with our economists to look at what's the economic benefits of segregation. Of course, we know that it's economically beneficial to remove the chalky kernels from the non-chalky kernels, but what about just individual cultivars? Is there an economic benefit to that? And so we are doing that, and depending on that study, I think we should be able to convince our milling industries to kind of come up with some guidelines that can help to segregate the rice kernels. Another area I'm also looking at is in the product development sector. You know, there are companies like Kellogg, you know, there are companies like Anheuser-Busch, you know, there are companies like Landberg Farms. You know, all these companies would benefit from individually preserved cultivars because they are making products that require unique attributes. For example, Anheuser-Busch would like to have unique flavors in their beer. You know, Kellogg would probably want to have some unique texture characteristics in the extrusion process or in their flaking process. You know, and so all these different market segments are really looking for unique characteristics in rice, and those unique characteristics is hard to achieve them, you know, when you are having a commingled rice cultivar. And so I'm doing a lot of tests in my group to look at what's the impact of commingling, for example, on the parboiling processing line. What's the impact of commingling on the instantization line? What's the impact of commingling in the brewing performance line or in the flaking performance line? And so it's a big topic, it's a big challenge, but we are doing work on that.
Yes, that's nice. Franciene, that works with us at Grano Safe, worked in her PhD with different hybrids and pure lines from Brazil, and checked how the gelatinization temperature, the dimensions of the kernels can change, and this will definitely impact on the end product quality of the parboiled rice. So that's a very interesting topic that we need to take care in Brazil too.
Right.
So Dr. Atungulu, I just want to say thank you for the opportunity to have this talk with you. It was our pleasure. It's a pleasure to Grano Safe to contribute with your group, with the University of Arkansas. And so thank you, and we'll keep the good work.
Thank you very much, and I really appreciate this time. I welcome you to and your teams to the University of Arkansas. Every year we have the Industry Alliance meetings that we hold in May, and so this will be another opportunity for you people to visit with us and learn what we do. So thank you very much.
It's nice. We appreciate. Thank you. Então, pessoal, esperamos que vocês tenham gostado deste bate-papo com o professor Griffiths Atungulu, da Universidade do Arkansas. E fiquem ligados nas plataformas da Grano Safe para mais conteúdos como este e outras informações que nós disponibilizamos por lá. Até logo!